Alright guys, let's first revise the two chapters that we have done already guys. So, statistical description of data guys. The first thing that we have done was the definition of the word statistics. I said statistics is nothing but collection of data guys, organization of data, and then guys presenting it in appropriate form so that it can be analyzed and you can draw inferences out of it. The origin of the word statistics guys, it is either based on the Latin word status or the Italian word beta statista. French word ends with QUE, German word ends with K. Statistic guys. And then definition of statistics in a singular sense, in a plural sense. I said when you talk about singular sense, you're talking about the methods that we use in collection and presentation of data, organization of data. In a plural sense guys, you're talking about the data itself, collection of data which can be qualitative as well as quantitative data. As far as application of statistics is concerned guys, you can talk about applying statistics in any field. It can be commerce, it can be businesses, it can be for government policies, but any field, even in medical research, but there will be application of statistics. After that beta, we spoke about the limitation of statistics. I said first limitation guys is that statistics deals only with aggregates. An individual observation will not be of much significance other than the fact that it is just a part of the overall aggregate. The second limitation of statistics beta is that it applies only to quantitative data. It does not apply to qualitative data. However, if there is qualitative data, you should be converting that into quantitative data for the purpose of performing statistical analysis. Third one beta is that whatever projections that you're making by applying statistical tools, they will hold good only if the underlying conditions based on which beta the projections were computed remain same. If the underlying conditions change, if the underlying assumptions change, beta, the actual scenario will drastically differ from the projections that we have made. I gave the example of COVID for that beta. The last one is statistical inferences drawn on the basis of the data that you have collected guys will be accurate or will be reliable only if the data is selected on a random basis. If the samples collected guys are biased, then the end result cannot be relied upon. Are we clear about this guys? After that guys, we spoke about data. I said data can be classified into qualitative data or quantitative data. As far as quantitative data is concerned, it is called as a variable, which is further segregated into discrete variable and a continuous variable. A discrete variable guys is one which will have finite number of possibilities within a given range of values. Marks of a student is an example of discrete variable. The number of misprints, the number of accidents, all of that beta will be discrete variable. If the total number of possibilities within a given range of values guys are infinite, the variable under consideration will be termed as continuous variable. Height, weight, age, profits of a company guys, income will all be examples of continuous variable. Though I said beta in our study material, they have marked income of a person beta as discrete variable and not as continuous variable. Then a qualitative characteristic guys is known as attribute. So gender of a person, nationality of a person beta, all of that will be attribute. Are we clear? After that beta, we moved on to dividing data guys into primary data and secondary data. Primary data is first hand information collected. Secondary data beta is using data which is already collected. For methods of collecting primary data, we have interview method, observation method, mailed questionnaire method. Questionnaire is filled and sent by enumerators. Under interview method, we have personal interview, indirect interview guys, and telephonic interview. Personal interview, as said guys, will be used in case of a natural calamity. Indirect interview will be used in case of a rail accident. And then beta, the last one, telephonic interview would have wide coverage among all the interview methods, and it will also have maximum number of non-responses guys under interview method. Observation method guys is used wherein you can directly measure a quantity, so you're not asking the respondent anything guys, you are in fact measuring the end value, which is the most accurate one, observation method, but it is also time consuming. Mailed questionnaire method mein beta, a list of questions is prepared and sent to the respondents. They are obligated to fill in that information guys and send it back to you. Obviously among all the methods guys, the maximum coverage would be under mailed questionnaire, but the maximum number of non-responses also will be under mailed questionnaire method. Questionnaires filled and sent by enumerators is similar to mailed questionnaire, wherein a list of questions is prepared, but then you will be personally asking those questions to the respondents and you will be filling up that information yourself. Are we clear guys? So as far as comparison is concerned, most accurate will be observation method, wide coverage is mailed questionnaire, maximum non-responses beta is also mailed questionnaire. Under interview method, already बोल चुका हूँ, wide coverage and maximum non-responses would be under telephonic interview method, with or without yawning. After that beta we moved on to organization and presentation of data. Now इसके पहले guys I also spoke about scrutiny of data. It is not there in this, but scrutiny of data में कुछ explanation नहीं है guys. It says in case there is related information given, you will have to check whether the relationship between those variables is holding good or not guys. That is checking for internal consistency. Otherwise guys, scrutiny of data is simply checking whether the data that is collected guys is reliable or not. How will you check whether it is reliable or not? Use your intelligence. Disclaimer. Yes or no? Next guys, after that we spoke about presentation and organization of data, wherein you divide the data guys into multiple groups based on their characteristics. इसके नीचे बेटा we also learned about another classification of data, which is chronological data and geographical data. Chronological data is also known as time series data. Geographical data, chronological data guys is also known as time series or temporal data. The other one, geographical data guys, is also known as spatial series data. And then the other one beta we already know, qualitative data and quantitative data. Quantitative data is cardinal data, qualitative data is ordinal data. You can assign frequencies guys only to qualitative and quantitative data. That is why they're called as frequency group. Frequency cannot be assigned to geographical data and time series data. So that will be called as the non-frequency group. Modes of presentation of data mein guys, you have textual presentation, tabulation and diagrammatic representation. Under textual presentation I told you that you present information guys using text. So yahan pe beta it says it is very simple to dull, but then you will know the exact value guys both under textual presentation as well as under tabulation. You will not be able to establish a relationship between the values guys, or comparison is not possible under textual presentation. Comparison is still possible under tabulation, but you will be able to identify hidden trends under diagrammatic representation. So comparison comes under both tabulation as well as diagrammatic representation. But if there's any trend that you would want to establish, it's easier to identify that trend under diagrammatic representation. Next guys, tabulation mein beta you are presenting the data using a statistical table. Yahan pe you should know what is caption, stub, then there is body and box head. Caption is the description of columns and sub columns. Box head guys is the entire upper part of the table that includes caption and also includes unit of measurement. The left part of the table that describe rows guys is called as stub. The main content of the table is called as body of the table. Then every table guys should be given a title, should be numbered, and then there should be footnote guys if there's any explanation required to the content that is covered in the table. Are we clear guys? Tabulation is a must for diagrammatic representation. Under diagrammatic representation guys, one important thing is that you will be able to identify hidden trend, and also it is less accurate. Why is diagrammatic representation considered as less accurate? If you would want to know the exact value at a particular point as such beta, the graphs may not be accurate as such guys. Agar scale बहुत ज़्यादा है, say for example 1 centimeter is equal to 10,000 units. Obviously you will not be able to exactly derive the value guys. But I told you this problem does not prevail guys in the current world because we all have digital graphs. If you have digital graphs as such guys, it will be easier to identify an exact value guys by simply pointing at that point in the graph. Now under this beta we did line diagram, we did bar diagram, and then we did pie chart. Line diagram is used only for time series data. You plot the corresponding time period guys on x-axis, the value guys on the y-axis. We will use logarithm of those values guys. Instead of plotting y values directly guys on y-axis, you will plot log of those values guys. You will plot log of those values guys when there is wide fluctuations as such guys in the values of y. That is why that is called as a logarithmic or a ratio chart. If there are multiple variables that have the same unit of measurement, we will be using a multiple line chart. Multiple axis chart is used guys when you have to compare two or more variables but with different units of measurement. Under bar diagram as such guys, again this can be used for any classification of data, whether it is qualitative, quantitative, time series data or geographical data. But then the commonly used bar diagram is vertical bar diagram, which we will use for time series data and quantitative data. Horizontal bar diagrams are used for qualitative data and geographical data, spatial series data. So under this beta you'll have to simply present consecutive bars. लेकिन ये bar diagram और histogram में difference क्या है? Histogram में बेटा there'll be no gaps between the bars because you're plotting class intervals on x-axis. यहाँ पे बेटा because you're plotting time periods, there will be gaps between those bars. So After this, guys, under bar diagram only, I said we will use multiple bar diagram or a group bar diagram when you have two or more comparable series with comparable data. You will use a subdivided or a component bar diagram, guys, when the variable under consideration has multiple components and you would want to compare those components as well. The same thing when expressed in absolute terms, beta, is subdivided or component. If it is expressed in percentages, it becomes percentage bar chart. Are we clear about this, guys? After that, beta, we did pie chart. I said pie chart is nothing but when you have to present the relationship between multiple components of a variable, guys, all of which are in relation to a specific time period. Most common example, beta, would be in relation to taxes or in relation to contributions of different products in the overall revenue of the company, or different cost components. You know the total cost of a product, you would want to know what is the contribution of each cost element there, beta. Are we clear? Pie chart may, if they ask us to compute angle, the sum total of all the components will be equated to 360 degrees. Are we clear, guys? Next, beta, we moved on to frequency distribution. Next directly. So frequency distribution, beta. Frequency distribution is nothing but a table as such, beta, that will show the values under consideration and their corresponding frequencies, the number of times that those values have occurred. So frequency distribution can be for an attribute, guys. It can be for variable. Is abhi padhe the beta that qualitative data and quantitative data belong to frequency group, meaning you can assign frequencies, guys, to both qualitative as well as quantitative data. So if it is an attribute as such, guys, you just have to write the number of times that specific qualitative characteristic has occurred. But usually frequency distributions that we have done, beta, are in respect of a variable. A variable related also, guys, I said it can either be for a discrete variable, guys, or it can be for a continuous variable. इसीलिए बेटा यहाँ पे we have learned about ungrouped frequency distribution and grouped frequency distribution. If frequencies are being assigned to individual values of x, guys, it will be called as ungrouped frequency distribution. If frequencies are being assigned to a group of values, guys, it will be called as a grouped frequency distribution. When I say group of values, I'm talking about class intervals. Now, usually because discrete variable has finite possibilities as such, beta, we say that ungrouped frequency distribution will be in respect of a discrete variable. That is why ungrouped frequency distribution is also termed as discrete frequency distribution or a simple frequency distribution. Likewise, continuous variable, because it has infinite possibilities as such, guys, you will use continuous grouped frequency distribution in respect of a continuous variable. I also asked you to remember keyword definition सिर्फ यहीं तक relevant है बेटा, because in reality we use grouped frequency distribution for both discrete variable as well as continuous variable. Now, when it comes to grouped frequency distribution, these class intervals that we are referring to, guys, can be on a mutually inclusive basis or it can be on a mutually, when you say mutually exclusive basis, mutually inclusive class intervals, guys, you include both the lower class limit and the upper class limit. Under mutually exclusive, guys, you include the lower limit, but you do not include you exclude the upper class limit. So that is mutually exclusive. A mutually inclusive mein beta class intervals can be like 1 to 10, 11 to 20, 21 to 30, guys. So because values can also be between 10 and 11 when it comes to a continuous variable, we use mutually inclusive classification only for a discrete variable. We are normally not supposed to use mutually inclusive classification, guys, for a continuous variable. But then there was a question, guys, in which they took the distribution of weights and in the material itself is better, they gave it as mutually inclusive. The very first example that was used for subsequent multiple questions, 49 to 53, 54 to 58, was in that weight distribution, but that was still a mutually inclusive classification. Theoretically speaking, you're supposed to use mutually inclusive only for a discrete variable. Mutually exclusive classification, guys, 0 to 10, 10 to 20, 20 to 30 jo hai, this can be used for a continuous variable as well as for a discrete variable, but normally better it is used only for a continuous variable. Are we clear about this? Class limits, guys, is the lower limit. Basically, guys, what is the minimum value and the maximum value that can be assigned to a class interval? That will become your class limits. If it is mutually inclusive classification like 1 to 10, 11 to 20, better your class limit will be 1 and 10, 11 and 20. If it is mutually exclusive classification like 0 to 10, 10 to 20, better class limit will be 0 and 10, 10 and 20. Now, in case there is a gap between the upper class limit and the upper class limit of one class and the lower class limit of the next class, that is in respect of mutually inclusive classification, limits will not be the same as boundaries. This is where I said boundaries are actually termed as the limiting values of limits itself. So you'll have to convert those limits into boundaries, guys, and that is done by adding 0.5 to the upper class limit and deducting 0.5 from the lower class limit. You have to be careful for all the subsequent chapters as such, guys. Reference is made only to class boundaries. So in case they give mutually inclusive classification, we will have to immediately add 0.5 and deduct 0.5, convert those limits into boundaries. Are we clear? For a mutually exclusive classification, there is no difference between the word limits and boundaries. They're all the same, guys. After that, beta, mutually inclusive, exclusive, okay. Length or width or size of a class interval is nothing but the total number of values, you know, that can come in a specific class interval as such, guys. So the area of the class interval should be written as upper class boundary minus lower class boundary. Never take the difference in limits, always take the difference in boundaries only. Midpoint or mid value, guys, or class mark. This is nothing but the exact middle point of the entire class interval. Now, why do we need this midpoint or mid value or class mark? Because we are now done with the subsequent chapters, guys. For computation of mean, we assume that all the values of a specific class interval are equal to its mid value. That is why, guys, we have to compute mid value. After that, beta, we did frequency density, relative frequency, and percentage frequency. इसके पहले बेटा we also did cumulative frequencies first. Cumulative frequency is the sum total of frequency up to a specific point. By default, it is usually less than cumulative frequency and not more than cumulative frequency. So you will write the corresponding class boundaries and write the sum total of frequency, guys, up to that point. So frequency density, guys, is frequency of a class interval divided by length of the class interval. When you say frequency density, you're talking about the total concentration of values, guys, in a specific class interval. Relative frequency, guys, will be frequency of a class interval divided by total frequency. That is nothing but probability again. Percentage frequency is the relative frequencies converted into percentages. So that's relative frequency multiplied by 100. Finally, we moved on to graphical representation, guys, of frequency distributions. The first one here, beta, is histogram. You plot class intervals on x-axis, the corresponding frequencies, guys, on y-axis. There should not be any gaps between those bars as such, guys. That is why you have to convert limits into boundaries. In case the length of the class interval is not uniform, instead of plotting frequencies, we plot frequency density so that it's easier to compare those frequencies. Okay. So after this, guys, I said among the measures of central tendency, we can compute mode using histogram. Mode is nothing but the point of intersection, guys. वो जो graph में था, upper class boundary of the model class with the upper class boundary of the previous class, lower class boundary of the model class with lower class boundary of the next class. इसका जो भी point of intersection होता है, that becomes your mode. Next, guys, we have frequency polygon. Frequency polygon में, guys, it's a limiting form of histogram. What you do, beta, is you pick up the mid values of all the class intervals and you plot only the mid values and the corresponding frequencies. Correct, beta Karman? You plot all the mid values and the corresponding frequencies on a graph, guys. If you join them by successive lines as such, beta, that will become frequency polygon. But to complete the frequency polygon, I said we have to assume two more class intervals. One class interval after the last one class interval before the first one. Pick up the mid values of these class intervals, take frequencies as 0. And complete the frequency polygon. Frequency curve किया था बेटा इसके बाद में. I said frequency curve is a limiting form of both histogram or frequency polygon. The only difference, beta, is that under a frequency curve, it's a freehand curve. The sum total of area of a frequency curve should always be considered as 1 unity. Types of frequency curve में बेटा, we have bell-shaped curve, we have J-shaped curve, guys, we have U-shaped curve, and we have mixed curve. The most commonly used or applicable frequency curve, beta, will be bell-shaped curve. Now that you have done mode ka calculation also as such, guys, for mode we assume that the concentration of values will follow a bell-shaped curve. You will have lesser number of values initially, they will reach its peak and again start decreasing. Then, guys, ogives or cumulative frequency graphs, guys, is wherein we plot your lower class boundaries, beta, and less than cumulative frequency or more than cumulative frequency. You have two types of ogives. You have less than ogive and more than ogive. The point of intersection of less than and more than ogive will become your, because it's a positional average. Exact point of intersection will occur at n by 2. N by 2 is nothing but your middle value of all the observations, guys, and that itself is your median. Even if you're not plotting more than ogive, guys, you can compute any partition value using less than ogives. So to compute any partition value using less than ogive, you will have to draw a perpendicular to x-axis from than ogive. But that will depend upon the position of that partition value. If you were to compute quartile 1, what will you do? n by 4, pick up n by 4 on that cumulative graph as such guys, draw perpendicular to x axis, जहाँ पे भी x axis पे point आता है, that itself is your quartile 1. Same way quartile 3 करना है तो 3n by 4. This is what we did guys in the first topic. Are we clear guys? Now better, the next one. Measures of central tendency guys and measures of dispersion. Measure of central tendency guys, central tendency is nothing but an average that is used to represent all the observations. Whenever you pick up a group of values as such guys, that group of values as such beta can be scattered. Obviously when you are stating those observations, you cannot present data in its raw form and state all the observations guys to whoever is reading that information. इसीलिए we present an average that represents the entire set of observations, and that average beta which measures the entire set of observations itself is called as your measure of central tendency. There are three broad measures of central tendency. We have mean, median and mode. Under mean also we have arithmetic mean, geometric mean and harmonic mean. So arithmetic mean is a mathematical average of all the observations which is derived by adding up all the observations and dividing it by the number of observations. So that is why arithmetic mean, that is x bar, equals summation xi divided by n. In case there are frequencies assigned as such guys, instead of adding those observations multiple times, you can also multiply each observation by the corresponding frequency. That is why I write it as summation fi xi by summation fi. So if you have ungrouped data, frequency data, you simply multiply xi values with fi. That is exactly the same as adding xi values so many times and then divided by the summation of fi. Okay. Next guys, in case you have grouped frequency data, you can still use the same formula which is summation fi xi by summation fi. Just that xi here beta would represent mid values of all the class intervals. That is how you will be arriving at arithmetic mean. Alternatively guys, because there is a property of arithmetic mean which states that the sum of deviations taken from arithmetic mean will be equal to 0, you can assume any value as the arithmetic mean and start computing deviations from that arithmetic mean. If the sum total of deviations is equal to 0, then the assumption is correct. If the sum total of deviations as such guys is not equal to 0, then you will have to make an adjustment, and that adjustment would be the average deviation, for which we will write summation fi di by summation fi. That if you adjust guys to the assumed mean beta, you will get your arithmetic mean. ये into c कब आएगा? Only if while computing deviations guys, you are dividing it by c, then subsequently you should multiply by c, otherwise there's no point in multiplying it by c. Then guys, अभी नहीं आया था, but वो later part we did weighted average arithmetic mean. I said weighted average arithmetic mean applies as such guys when you are usually talking about expected values that can arise on a later date, for which you are arriving at different scenarios and we are arriving at different probabilities or different weights. Ki what is the likelihood of a particular observation occurring? So if all the observations do not have an equal chance of occurrence, you cannot take a simple average, you will have to take a weighted average. The formula is exactly same as frequency data ka formula. You're just replacing frequencies by weights. Are we clear guys? Now as far as the properties of arithmetic mean are concerned guys, the first property was if all the observations are equal to a constant k, arithmetic mean also will be equal to constant k. Second one guys, if the sum total of deviations taken from arithmetic mean will always be equal to 0. Next beta, arithmetic mean is affected by both change of origin and change of scale. Shruti thoda side mein ja beta. Arithmetic mean guys is affected by both change of origin and change of scale. Change of origin is where you add a constant value to all the observations. Change of scale is where you multiply a constant value to all the observations. So that relation is given as y is equal to a plus bx. So if you know x bar, you simply substitute in this equation guys and compute y bar. Even if the equation is not of the form y is equal to a plus bx, if they give a random equation like 3x plus 2y plus 10 is equal to 0, simply substitute x ki jagah x bar, compute the value of y, that itself will be y bar. For mean, there is no point in converting the equation in the form of y is equal to a plus bx. Substitute karo, get the answer. The next property beta was in relation to combined mean. Because mean is a mathematical average, you will be able to arrive at the mean of two different groups of observations. For that beta, you will write n1 x1 bar plus n2 x2 bar divided by n1 plus n2. There were a couple of examples that I gave in relation to this beta which were important. Next measure of central tendency guys is median. Median is a positional average. So median is simply guys, if you arrange all the data, all the observations in ascending order or descending order guys, whichever observation comes exactly at the midpoint that will become your median. So in case you have odd number of observations as such, guys, there will only be one middle value. So that itself will be your median. In case you have even number of observations, you will have two middle values, guys. An average of those two middle values will become your median. Now, alternatively, guys, you can also write position of median is equal to n plus 1 by 2. And that whatever observation occurs at n plus 1 by 2 beta itself will be your median. Just if I have 10 observations, n plus 1 by 2 beta will become 10 plus 1 by 2, 5.5. How will I compute median using 5.5? Fifth observation plus 0.5 of the difference between sixth observation and fifth observation. Are we clear about this, guys? Likewise, beta, if you have grouped frequency data, guys, the position of median, guys, will not be n plus 1 by 2, it will be n by 2. It is mandatory, beta, that you arrange the data in ascending order only, not in descending order, because all the other partition values are based on ascending order. Once you compute n by 2, guys, you will have to identify the class interval, guys, in which that observation occurs, and that can be identified by writing cumulative frequencies. Once that is done, calculations are done on a proportionate basis. I've derived this formula in the class, but I said it is nothing but assuming that the observations are uniformly spread throughout the class interval. For mean, we assume that all the values are equal to its mid value, but for median, we assume better that the values are uniformly spread. That is how we derive the formula, which is L1 plus n by 2 minus NL by NU minus NL into C. Are we clear about it? Next, beta, as far as other partition values are concerned, guys, we have quartiles, we have deciles, we have percentiles. Quartiles divides all the set of observations into 4 equal parts because you need 4 divisions, guys. There will only be 3 partitions that will be required. So you will have quartile 1, quartile 2 and quartile 3. The position of quartile 1 would be, if it is ungrouped data, n plus 1 by 4, quartile 3 will be 3 times of n plus 1 by 4. If it is grouped data, guys, you will write n by 4 and 3n by 4. Are we clear, guys? Deciles divide all the set of observations into 10 equal parts. That is why you will need 9 partitions. So you will have decile 1 to decile 9. So to compute the position of decile, guys, you will write n plus 1 by 10 into whichever decile you want. If it is grouped frequency data, directly n by 10. The same thing for percentiles, beta, would be n plus 1 by 100 for ungrouped data. For grouped data, guys, it will be n by 100. Calculations are exactly the same as median. If they ask how many percentage of values are less than quartile 1, the answer is 25%. How many percentage of values are more than quartile 1? 75%. More than quartile 3? Less than quartile 3? 75%. Alright, guys. They can ask those percentage of values also, guys. Now, as far as the properties are concerned, guys, regarding median, the first 2 properties, beta, will hold good. If all the observations are equal to a constant k, guys, then median also will be equal to a constant k. Median is also affected by change of origin and change of scale. Therefore, if y is equal to a plus bx, median of y will be equal to a plus b times of median of x. Here, guys, there is no such property called as sum of deviations will be equal to 0. Instead, we have sum of absolute deviations. But sum of absolute deviations can never be 0. You're ignoring the sign. So the property that we have here, beta, is that sum of absolute deviations will be minimum when they're taken from median. And median, guys, is not based on all the observations. It is not a mathematical average, so it will not have mathematical properties. So there's no formula called as combined median. Are we clear about this, guys? It is the least affected, guys, by extreme observations because it is the middlemost value, guys. Proud of you, beta. And sampling fluctuations, guys, it is affected higher than mean. The impact of sampling fluctuations would be higher on median and lower on mean. Mode, guys, is the item, beta, that occurs the highest number of times. So all you have to do, beta, to compute mode is identify the item that occurs the highest number of times. So if individual observations are given, you identify mode directly. If ungrouped frequency data is given, whichever observation has the highest frequency. If grouped frequency data is given, guys, we assume mode will lie in the class interval with the highest class frequency. Within that also, beta, we assume that the distribution of values without yawning will be bell-shaped. Yes or no? That is why, beta, to compute mode as such, beta, histogram ka logic applies here because the concentration of values is bell-shaped. You will write L1 plus F0 minus F minus divided by 2F0 minus F minus 1 minus F1 into C, which is length of the class interval. Are we clear? As far as properties or mode of concern, guys, कुछ नहीं है बेटा. One is वही If all the observations are equal to a constant k, mode also will be equal to that constant k. Mode, guys, is one observation which is not rigidly defined. So if all the observations occur equal number of times, there is no mode. At the same time, there can also be more than one mode. Are we clear? If there's only one observation occurring multiple times, that itself is a mode. Mode is affected by both change of origin, guys, and change of scale. After this, guys, we also did the relationship between mean, median, and mode. What was that relationship, beta? Mode is equal to 3 median minus 2 mean. I said that this relation will hold good, guys, only if the skewness is moderate. Skewness, guys, is the inclination, guys, towards the left or the right as such, guys. So if it is zero skewness as such, beta, then mean, median, mode sub same रहेंगे. There'll not be any difference only, guys. Next, beta, if all the observations occur only once, mode is not defined. हो गया. Next, guys, we moved on to the other means, guys. We had geometric mean and harmonic mean. Geometric mean, guys, is the nth root of product of n observation. So you will write nth root of x1 into x2 into so on xn. If frequency data is given, guys, you will write x1 to the power f1, x2 to the power f2, x3 to the power f3, so on till xn to the power fn. Yes or no, guys? Now, geometric mean, guys, can be used only if all the observations are positive. If you have even a single negative observation, guys, the product might become negative. That is why, guys, we do not use geometric mean. Geometric mean considers the compounding impact. As far as the properties of geometric mean were concerned, guys, if z equals xy, then geometric mean of z will be equal to geometric mean of x into geometric mean of y. Likewise, if z equals x by y, beta, geometric mean of z will be geometric mean of x by geometric mean of y. If all the observations are equal to a constant k, guys, then geometric mean also will be equal to that constant k. Log of geometric mean, guys, will be the arithmetic mean of logarithm of the observations. Log g is equal to 1 by n into summation log x. Are we clear? You get geometric mean. Harmonic mean, guys, is the reciprocal of the arithmetic mean of the reciprocal of the observations. So you first invert the observations. Xi values are given. You first compute 1 by xi. Then take arithmetic mean of 1 by xi. That will be summation 1 by xi whole divided by n. Then take reciprocal of that also. That is why harmonic mean is equal to n divided by summation 1 by xi. If frequency data is given, summation fi divided by summation fi by... Because harmonic mean also, beta, is a mathematical average. Is a formula for combined harmonic mean as such, guys. Combined geometric mean agar compute karna as such, guys, you can, guys. Say if there are 10 observations and you know geometric mean of those 10 observations is 15. The product of those 10 observations is 15 power 10. Socho practically. I do not need individual observations. I know the product of those 10 observations will be 15 power 10. Let's say, beta, I have 8 more observations whose geometric mean is 12. So the product of those 8 observations as such, guys, will be 12 power 8. Now I need combined product. 15 power 10 into 12 power 8. Iska whole power 1 by 18. Are you getting the point, guys? You can easily arrive at combined geometric mean because you can find out the product. So combined harmonic mean, beta, formula is n1 plus n2 divided by n1 by h1 plus n2 by h2. Now both geometric mean and harmonic mean, guys, are also affected by change of origin and change of scale, but you will not be able to establish an accurate mathematical relationship, guys. There's no linear relationship that will exist, guys. That is why, beta, we do not discuss that as a property. If all the observations are equal to a constant k, guys, then geometric mean and harmonic mean also will be equal to that constant k. I said, beta, that harmonic mean is used for computing average speed. Remember, speed when given, guys, is itself an average. That is why when you take an average of an average, you cannot directly consider arithmetic mean. So we consider harmonic mean, which gives us a more accurate value. Geometric mean is used, beta, for compounding impact. That is why if they give, beta, average rates or speeds as such, guys, you will have to mark the option as geometric mean and harmonic mean. Most appropriate for average speed, rates and ratios, guys. Median is the most appropriate classification for open-end classification. Why is it the best for open-end classification? You don't need the lower class boundary of the first class. You do not need the upper class boundary of the last class. That is why it is the most appropriate, guys, for open-end classification. AM is the most commonly used measure of central tendency, guys. Popular measure is mode or sampling fluctuations का impact already बोल चुका हूँ बेटा. Sampling fluctuations का impact would be higher on median, lesser on mean. Mean satisfies all the measures, ideal criteria, guys, for a measure of central tendency. What is the list of ideal criteria, guys? It should be based on all the observations. It should be easy to comprehend, beta, simple to calculate. It should have mathematical properties. It should not be affected by extreme observations. Now mean beta is satisfying all the properties except beta that mean is affected by extreme observations, because you take all the observations into consideration, guys. Extreme observations is going to impact your mean. Let's say if you talk about per capita income as such, guys, are you not taking all the incomes of all the individuals, guys, of the country beta? Yes or no, guys? You cannot go by that per capita income as such, guys, because there are people who are earning in billions and billions as such, beta. Those are extreme values. Number of people who belong in that category is very less, but that is still influencing the overall average. Are we clear about it? ये हो गया मीन के बारे में बेटा. मीडियन के बारे में भी, guys, I said median and mode do not have mathematical properties. Geometric mean and harmonic mean do have mathematical properties. Anything else, guys, in mean, median, mode? Yes, as far as the relation between AM, GM and HM is concerned, guys, no matter what happens, AM will be greater than or equal to GM, will be greater than or equal to HM. If the observations are all the same, guys, then the relation is AM is equal to GM is equal to HM. But if there are distinct positive observations, guys, AM will be greater than GM, will be greater than HM. Also, if you have only two observations as such, guys, A and B, then square of geometric mean will be equal to the product of arithmetic mean into harmonic mean. G square will be equal to A into H. Anything else? Now, guys, moving on to measures of dispersion. I said measure of central tendency, guys, measures the concentration of values. Anyone wants to leave, they can, guys. It measures the concentration of values better. Likewise, not necessary as such, guys, that all the values should be equal to that measure of central tendency. Individual observations as such, guys, will be obviously few observations will be more, few observations will be less than the average. That is why, guys, we also need the extent to which the values can deviate by. So for that beta, we have measure of dispersion, which measures scatteredness of the observations. By how much can the values fluctuate from the measure of central tendency. Finance के दुनिया में बेटा इसको risk बोलते हैं. Higher the amount of deviation, higher will be the risk involved in the security in the investment that we are talking about. So as far as measures of dispersion are concerned, guys, we have absolute measures of dispersion and relative measure of dispersion. An absolute measure of dispersion, guys, is computing dispersion only for that variable under consideration. A relative measure of dispersion, guys, is comparing absolute measure, guys, with some measure of central tendency. Why do we need relative measures of dispersion? You cannot compare absolute measures of dispersion, guys. This is why we need relative measures of dispersion. I gave an example. I said, guys, what if security A is fluctuating by 5 rupees, security B is fluctuating by 5 rupees. That is absolute dispersion. On the basis of this information, we may conclude that both of them have the same dispersion levels. But what if the average price of security A is 5 rupees, average price of security B is 10,000 rupees? A 5 rupees fluctuation on 5 rupees would be way too high, guys. A 5 rupees fluctuation on 10,000 is nothing. Are we clear? This is why beta we need relative measures of dispersion. So in this chapter beta, absolute measures will have the same unit of measurement as the underlying variable. A relative measure of dispersion is a unit free measure. Anywhere, guys, wherever you come across relative measure, it is always a unit free measure. Are we clear about this? Now, talking about absolute measures of dispersion, guys, you have 4 categories. You have range, quartile deviation, mean deviation, standard deviation. For each of them, beta, we also have a relative measure. So that is coefficient of range, coefficient of mean deviation, coefficient of quartile deviation. For standard deviation, the wording beta is coefficient of. The common properties for all of them beta are 2. If all the observations are equal to a constant k, guys, any measure of dispersion will be equal to 0. And then, guys, any measure of dispersion will not be affected by change of origin. It is only and only affected by change of scale. Also, guys, a measure of dispersion itself means that it is fluctuation or deviation, which implies deviation can be in any direction. That is why you do not assign a sign to it. When you do not assign a sign, guys, when the relation is of the form of y is equal to a plus bx, you will write measure of dispersion of y should be equal to mod b into measure of dispersion of x. Alternatively, beta is said, whatever is the equation given, ignore the constant term, substitute the value of x, compute the value of y. In case you get a negative answer, ignore the sign. This is for measure of dispersion. Correct, beta Tarang? Now, the first measure of dispersion, guys, is range. Range, guys, is the most. It's the most useless measure, guys, of dispersion because it only takes the two extreme values into consideration. Range is the difference between the largest observation and the smallest observation. In case you have grouped frequency data given, guys, because you do not know the individual observations, largest observation would be the upper class boundary of the last class interval. Smallest observation, guys, will be the lower class boundary of the first class interval. This is where beta you will directly write range again is equal to L minus S. Coefficient of range beta will be equal to L minus S divided by L plus S into 100. Range, because it is based on the two extreme values, guys, it is the worst affected by extreme observations. Baki properties same beta. Moving on to the next one, guys, mean deviation. The name says beta mean deviation is the arithmetic mean of deviations, but because you cannot directly consider deviations, few deviations will be negative, few deviations will be positive. Instead of taking normal deviations beta, we take absolute deviation. So what you do beta is you identify the arithmetic mean of absolute deviations. These absolute deviations again beta can be considered either from mean or median or mode. So the first step in computing mean deviation is identify from where are we supposed to take deviations. It can be mean, median or mode. Then compute absolute deviations from that measure. Then take an arithmetic mean of absolute deviations. Hence the formula beta is summation xi minus a divided by n. That a can be mean or median or mode. If there are frequencies given beta, you will write summation fi into xi minus a divided by summation fi. Coefficient of mean deviation compute करने के लिए beta, you will have to divide mean deviation by either mean or median or mode. Now, as far as the properties of mean deviation are concerned, guys, दो properties अभी भी same है. The other property in relation to mean deviation is it will be the least when the deviations are considered from median, because sum total of absolute deviations are minimum beta when they're considered from median. Next, guys, we moved on to quartile deviation. Standard deviation पे इसके बाद में आता हूँ. Quartile deviation, guys, is an average of deviations beta between the quartiles. So 3 quartiles deviations will be Q2 minus Q1, Q3 minus Q2. इसका average beta itself is your quartile deviation. So that is why it is Q3 minus Q1 divided by 2. Divided by 2. That is your quartile deviation. To compute coefficient of quartile deviation beta, you will have to divide quartile deviation by median into 100. Formula for arriving at practical values beta will be Q3 minus Q1 divided by Q3 plus Q1 into 100. Alright guys, वो grouped रहने दो, ungrouped रहने दो, कुछ फर्क नहीं पड़ता. Now the property that is in specific beta to quartile deviation is it is the best measure of dispersion for open-end classification because it is based on central 50% of the values. It is not affected by extreme observations, but it is still not a mathematical average because we are doing it on the basis of the position of those values. Next, guys, we moved on to standard deviation. Standard deviation is a mathematical formula beta, matlab it is based on all the observations. It is the square root of the arithmetic mean of the squares of deviations. Because you cannot directly take, guys, an average of deviations, we first square the deviations, guys, and then take the arithmetic mean of those squares of deviations and then take the root of that value. So the formula is under root summation xi minus x bar whole square by n. But I said this can be simplified better to summation xi square by n minus x bar square. If there are frequencies given better, before xi minus x bar you write fi, and here also better you write fi. Are we clear, guys? Next beta, because standard deviation, guys, is not affected by change of origin and is affected by only change of scale, I said instead of directly picking up xi values, you can also pick up deviation values, guys. Deduct a common value from all the observations. The formula that we did better there was summation fi di square divided by summation fi minus summation fi di by summation whole square. Are we clear about this, guys? Now, the square of standard deviation is called as variance. Coefficient of standard deviation will be equal to standard deviation divided by mean into 100. Because standard deviation is based on all the observations, we do have formula for combined standard deviation beta, which will be root over n1 s1 square, n2 s2 square, n1 d1 square, n2 d2 square by n1 plus n2. Here d1 and d2, guys, are deviations of individual means from the combined mean. So d1 will be x1 bar minus x bar, d2 will be x2 bar minus x bar. And then beta, if there are only two numbers given, standard deviation of those two numbers, guys, will be equal to mod of a minus b by 2. Standard deviation of the first and natural numbers, guys, will be equal to root over n square minus 1 divided by 12. Remember them as formulas. Okay. Properties में बेटा, if all the observations are constant, already पढ़ा चुका हूँ. Any measure of dispersion will be equal to 0. Any measure of dispersion is only affected by change of scale and not by change of origin. Mean deviation is minimum when deviations are considered from median. Quartile deviation is most appropriate for open-end classification. Range is the worst affected by extreme observation. Standard deviation is most commonly used measure of dispersion. और कुछ था बेटा उसमें? Whenever the question is about checking for consistency, guys, or variability of the data, you will have to measure relative measure of dispersion, preferably coefficient of variation, guys, because it is mathematically accurate. Whichever set of data, guys, has a lower coefficient of variation, that information, guys, or that set of data would be more consistent. If they ask for consistency, select the lower value. If they ask you to find out which is more variable, guys, you will have to pick up the set of data, guys, which has a higher coefficient of variation. Are we clear? That's it? Sure, guys. Chalo beta, let's end and start the next unit.